Good morning, everyone. So let me share my screen. Just wanted to rename this to Kafka instead of Incline. And here, I just wanted to go inside this and open this in IntelliJ ID. Trust it. Okay. Yeah. So before going further, I just wanted to, just go to the previous batches. And we'll just go through some presentation over here. Okay, so it's really required because we cannot go to the practicals unless we cover the things. So there's a second screen which is visible to everyone. Yeah, yeah. So first of all, I just wanted to do some theoretical introduction about Kafka, and then probably we'll see that in practicals. Okay, so Kafka is a open source distributed streaming platform for handling real-time data. Okay, so what do you mean by real-time data over here? Okay, so real-time data in the sense it's a live data. Okay, so what is this distributed streaming platform? Okay, distributed in the sense, so there will be a lot of applications which will be interacting with the Kafka, right? It has to be a distributed environment first of all. Okay, so let me tell you one simple thing. So Git is a centralized version control system or a distributed version control system. Can you tell me about this answer first of all? Git is centralized or distributed version control system? No one knows about it? Huh? You don't have to raise your hand, Suresh. Just so it's basically a Git is a distributed version control system. Okay, where each and every developer will have their own local repository. Whatever the remote repositories are going to have the same kind of data or the information. So each and every developer, if they are going to have the clone of the Git repository, they will be having the same copy which is existed in the remote repository also. So it's a distributed version control system. Okay. So let me tell you about this distributed streaming platform, right? So there will be n number of microservices in the world of microservices, right? So each and every service has to communicate with this particular distributed streaming platform. That means one service can produce some messages to the Kafka, and other services are going to consume the messages from the Kafka. So this is how it has to be distributed. Otherwise, it will not support in terms of multi layered architecture like microservice based architecture. Okay, and it follows publish subscribe messaging paradigm where producers publish messages to the topics and consumers subscribe to those topic in order to receive the messages. Okay, so this is something like publishing the data and subscribing to the data. Okay, we'll be having the Kafka publishers and listeners in our application, in even in booking service or in the payment service, we need to establish or write a code for publishing the data and also subscribing to the data. So we'll see that later when we actually do hands-on. Okay. Kafka is highly scalable and can handle massive amount of data. And again, I'm saying that since Kafka is an open source, right? Our system, CPU, and based upon the logical processors, it can scale to n number of instances. We will see what is the scaling and all this kind of things in a bit. And it also ensures fault tolerance by replicating data across multiple brokers. That means when we actually run Kafka, right? So we actually, implement some brokers for the Kafka. So these brokers are basically, so I will tell you about what is a broker in a bit in the next slide. This is actually, these brokers are actually used to prevent some data loss, even if one of the brokers are down or crashed. Okay, and Kafka is being used in event sourcing architecture like microservices event-driven architecture. So we can actually use Kafka as a distributed platform for for a couple of microservices or more number of microservices. They can interact with each other through this distributed streaming platform. So that's the general idea. Okay, and now let's understand what is the Kafka broker first. Okay, so Kafka broker is a server that forms part of the Apache Kafka distributed messaging system. So Kafka broker is just like a server where it actually maintains the Kafka topics as well as the storage informations. Okay, so it acts as a mediator between the producers and the consumers in a Kafka cluster. Okay, so first of all, what is a cluster? Let me explain that. Okay, so let's say right now we are having a booking service and we are going to have a payment service. Let's say what happens if the payment service is down? We are actually communicating with the payment service from the booking service normally through the FAIN client, right? So it's a HTTP call. Once the service is not available, let's say the payment service is down, whatever the call that we are going to make to the payment service, the data is lost because the service is not up and running, right? The payment service is not up and running. So in that particular case, probably all the data that we just wanted to send through or over the HTTP call, the data may be lost. Okay. So how Kafka helps in such situations, right? So we have something called, topics in Kafka, where we actually store the data in terms of partitions. I will also explain you about the partitions, but let's go through some theoretical aspects to understand what are Kafka brokers. Okay, so Kafka broker is just like a server where it actually maintains the storage as well as it is going to manage the Kafka topics. Okay, so we actually run Kafka as a cluster. So when we actually run Kafka as a cluster, cluster means it's a group of brokers. Let's say I just wanted to run one broker inside Kafka cluster. Okay, so cluster is just a configuration of brokers. Okay, what is a broker? Broker is basically going to interact with the topics, the storage. Okay, so let me tell you, if we have one single broker inside a cluster, what happens, right? If the broker is crashed, then probably the broker will be down. So here what we will be doing, we will be doing some set of configurations in order to maintain 3 or 5 different brokers or 10 different brokers or even 15 brokers or even 100 brokers according to the system requirements. Okay, so now what I just wanted to say, if you just wanted to maintain 3 different brokers, let's say even if if one broker is down, the data will be replicated from other brokers as well. So these brokers are basically used for achieving the fault tolerant mechanisms also. Let's say there is a broker, okay, and we do have some topics attached to it, and there is another broker, we do have some topics attached to it. But all these brokers and the associated topics are going to, synchronize the data between themselves. Let's say even if the broker 1 is down, the topics are not available. It will just take the help from broker 2 and it will get the data. So each and every broker is synchronized over here. Okay. And cluster is a place in Kafka where we actually run all these brokers as a group so that even if one broker is down, we'll get the data still from the available brokers from the cluster. So if you have a question, let's say the three brokers are down, okay? There cannot be a scenario that all the three brokers are down, okay? There will be only one scenario where we will be having only one single broker, okay? So we just wanted to maintain the broker at any cost up and running. But one single broker cannot handle a load, right? So we are going to scale that one by increasing the number of brokers to three. So we'll see that in action, okay? So first of all, I just wanted to discuss about Zookeeper. So Zookeeper is basically the base to run Apache Kafka. Okay, so Zookeeper serves as a distributed service for Apache Kafka, managing the tasks such as broker registrations and configuration management. So I have said you about Kafka Broker, right? So Kafka Broker basically, stores and manages the Kafka topics. So here, Zookeeper is the main server which is going to act like as a distributed service for the Kafka, which actually does the broker registrations and all these kind of things. So Zookeeper, you can basically analyze that. Without Zookeeper, Apache Kafka will not run. So first we need to run Zookeeper, then we need to run Kafka, okay? And Zookeeper also ensures the coordination and synchronization among brokers in Kafka cluster. I said to you, right? If there are three brokers and all the three brokers will have their associated topics, so even if one of the broker is down, the data is still replicated and synchronized among all the other brokers. So we can still get the same data even if one of the broker is down. So Zookeeper is just going to ensure that kind of coordination and communication as well as synchronization among the brokers in a Kafka cluster. Okay, so let me tell you about the Kafka template. Okay, so Kafka template is basically used to send messages to the Kafka topic. So it is basically a key component, from Apache Kafka framework. It is just going to serve as a high-level abstraction for interacting with Kafka topics. Okay, so the code that I have written over here, it's just a Kafka template. So string comma string. What do you mean by string comma string? Right here, the first key is just a topic name where we need to send the data, and the second value is the data itself, the data that we just wanted to store inside the topic. So this is how we can actually use this .kafka template send of the topic name and the data that we wanted to send to the topic. Okay. So now that is the Kafka template, which is actually used to send the messages to the Kafka topic. And this is a listener where, let's say, this is a payment request topic, right? So here we are actually sending the data to the payment request topic. So once the data is published into the payment request topic, immediately this Kafka listener is going to execute on the fly. Okay, so this listener basically listens continuously to the Kafka topic, and whenever there is a message coming in, it will just take that message in the form of the string. That means here we have actually sent the message using the topic as a key and data as a string. Okay, that data can be a string in the form of a huge level, a massive JSON data structure also in the form of string. Okay, so now this listener annotation is a part of Spring Kafka project, and it is used to indicate that annotated method should be invoked to process Kafka messages from the Kafka topics. Very, very simple. Okay, and that's the theory lecture about the Kafka. Okay. Terala Krupa. Search in Google, Terala Krupa. Okay, search in Google. So Kafka is, highly massive and highly scalable. It doesn't have any restrictions, but for RabbitMQ, there are lots of restrictions. You can read it over the Google. Google will give you a very good answers. Okay. Don't ask this type of, questions to me, Krupa, because uh, whenever you are asking something, make sure that that answer doesn't exist in Google, first of all. Okay. First you explore, and then if you have any questions, you can ask me. Okay. But Kafka is highly, scalable, and it provides a lot of features apart from RabbitMQ, especially in terms of scalability and fault tolerant mechanisms. Okay, so RabbitMQ doesn't provide all those kind of things, Krupa. Okay, so that's the major point I just wanted to tell you. Okay, so here I just wanted to go to this, and I just wanted to copy some of the code over here. I do not recommend people to install Kafka in their machines because Kafka requires a massive setup. You cannot install Kafka, it will take a lot of space in your laptop. So I just wanted to go and copy the existing one from this Kafka Docker, which is an infrastructure. Let me go to this one and go inside this and paste it over here. Yes. I'll just go to this volumes, Kafka, broker one. I just wanted to remove all this kind of things. Okay. So first of all, let me explain you about this things. So I said, right, so Zookeeper is the base to run Apache Kafka. Okay. So here, I just wanted to open this Docker file because we cannot install Kafka in our local machine. It requires a massive setup. It requires a lot of space on your system. It's better to use Docker images, and everyone is going to use Docker images as official images, or different companies will have their own registries where they can actually get this Kafka and Zookeeper on the go. Okay. So here, what I just wanted to say. So here, so I have actually taken this. I have not written any YAML files. So this YAML files are already available and provided by the Confluent Inc. Things. So I can actually, where's this one? So Kafka, Docker Confluent Inc. So here I have got this Docker Recompose YAML file, and I have actually divided that into two different files. If you just go inside this, so this is basically the Docker images which we can run in our local machine to make the Kafka up and running, so that we can test our applications with Kafka. Okay, so here there is a Zookeeper. They have actually used the same thing over here, and I'm also using the same. And here they have actually used a broker. They have actually used a schema registry. They have actually used SQL, CLI, KSQL data gen, all these kind of things. But for us, what we actually require, so this is a Zookeeper. It has the image. This is a official image from the Docker Hub. Okay. And they are going to give the host name as Zookeeper. And this is where the port Zookeeper is basically runs 2181, and we are exposing it as 2181. And this is some environment configurations. You don't have to worry about this because this is just a Docker file, YAML file, where it actually has some configurations to run Zookeeper and Kafka. And let's go to this Kafka cluster first of all. And if you go over here, so there's a schema registry. Okay, so you all know about Eureka server, right? Eureka server is just going to act like as a service registry where we actually register our microservices. Like the same way, here in Kafka, we do have brokers. Brokers are basically going to manage the Kafka topics, right? So here, schema registry is basically, it is also an image schema registry. This is actually from Confluent Inc. organization. So this image is from, and we can actually give the same name as a service name. And here it actually depends on Kafka brokers. So we can actually give this one, depends on attribute. And this schema registry is just going to run on 8081. And these are the environment variables. And here we have actually created Kafka broker 1, 2, and 3. Okay. So each and every broker is going to have a port 1092, 29092, and 39092. And this is a Kafka Manager service where it actually provides a very good UI to see our topics visually. Okay, so here I have actually made it as restart always, and the port is 9000. So let me tell you how this is actually gonna work. Okay, so now I just wanted to open the terminal and I just wanted to clear this first of all. Let's go to this infrastructure and do Docker compose hyphen F, because there are so many files, it doesn't know which file to run, right? When we actually do Docker compose up, it can actually run this one or this one or this one, because there are three files, it doesn't know which file to run, okay? So Docker compose hyphen F, first we need to run Zookeeper because this is the base to run Apache Kafka, and you can actually keep it as up. Docker compose up, so before up, we have to mention the YAML file so that it can actually run the Zookeeper. So now initially what it is going to do, since the Zookeeper is not available on my system, it is just going to download that image. And this is almost 271 MB, but if you just see Kafka, it is almost 1 GB. Okay. So we are just running this Zookeeper and it is just going to pull some data from the Docker Hub. Just wait for some time. And I just wanted to make sure that if anyone is going to run this application, they must have a very good internet connection with a strong network bandwidth. Otherwise, you will not be able to run this application and not be able to make up the Zookeeper and the Kafka running on your system. Okay, but this is just a one-time download. Once it is downloaded, you can just use it any number of times. Okay, now the Zookeeper is up and running. Now what we can do, we can actually go to the infrastructure folder, and here Docker compose hyphen F and Kafka up. That's it. So now it is going to, can you see this? This is almost 87 MB. This is 50 MB. And this is almost 879 MB. So it is almost equal to 1 GB. Got it? So that's the total idea. So it requires a massive setup, and if you're just going to download Kafka, I think don't install Kafka in your local machines. That is not recommended, first of all. Okay, so always use Docker images and play with it whenever you want. But just wait for some time. I think I'm in office. The internet is too slow, but in my home, there's so many people around here, right? So that's the total idea. Just wait for some time. I think 1 or 2 minutes. So first it is going to start the schema registry where it can have the registration of the brokers through Zookeeper. Zookeeper has to be there, otherwise the broker registrations will never be done. And I will also show you the UI, how it actually looks once this is done. Yeah, I think it is getting started. Okay, I think it is up. Just wait for some time. Yeah, the Kafka manager is also up. Okay, so now I have a script over here. This is just a bash script. So you don't have to worry about all these kind of things. I have not written this. Okay, I have just get it from the official GitHub page of the current printing. So here we have something called the commands to delete the existing Kafka topics and also to create the topics for the payment request and the payment response. Okay, so now I just wanted to open another terminal, cd infrastructure, go to the infrastructure folder and then clear it and then do docker compose -f Kafka. Sorry, this is the init Kafka, right? And do up. So now it is going to delete the existing topics if anything is there, and then it is going to create the topics, and then it is going to shut down. This is just a script, right? It doesn't has to run continuously. So now it has successfully created the following topics. Now I said that, right? So inside this Kafka cluster, this Kafka manager is like a UI. Okay, so this is just going to run on localhost 9000. So let me go and open this localhost 9000, and this is a Kafka cluster. Okay, so now I just wanted to add a cluster. I just wanted to view this as a movie ticket booking system. And then, so for this cluster, I have actually given the host name as Zookeeper2181, right? I just wanted to give the same thing. That's it. And now you can just go and save it, and then go to the cluster view. And here you can see that there are payment request topic and payment response topic. Okay, so we have actually created these topics. So these topics can be used by the booking service, the payment service, the notification service. Right now, we don't have notification service, but notification service I will be giving you as a homework, but not now. We'll just see it later. I just wanted to give one use case so that I just wanted to see how you are going to use that. Okay. So now we do have the payment request topic and the payment response topic where we can actually store the booking related details from the booking service to the payment request topic. And once the payment is successful, we are just going to pass the booking details back to the booking service through the payment response topic. Okay, and here you can see that we have actually created three brokers, right? So there are three brokers for each and every. So for this topic, there are three brokers, and for this topic, there are three brokers. Now I'll just explain you about these partitions. Okay, so if you just see your house has been divided into 3 or 4 different partitions. One is for kitchen, right? One is for bedroom, another one is for hall, and another one is for study room or studio room, whatever you do have. Okay, we are actually going to partition the house into 4 different or 5 different partitions so that we can have it individually, right? So the same like topic also has some partitions. So basically these partitions are just going to allow Kafka to scale as much as possible as it can, right? So let me explain you about these partitions, okay? So partitions give a lot of advantages to the Kafka topic in order to scale up or scale down, okay? Let me explain you what is scaling. So let's say payment request topic is being used by 3 different microservices at the same time. That means the first microservice can use one partition to store the data. The other microservice can use the payment request topic in order to store the data inside the partition 2, because first partition is already taken control by another microservice. So it actually speeds up the storage, and also it is actually going to provide a parallelism between the storing of the data. Okay, so partitions basically allows the Kafka topics to scale. Okay, I was just lost for a moment. So payment request topic, this is just going to contain some partitions, right? So these partitions basically allow to scale, to basically give you a scalability feature. So if any of the service is just going to read from payment response topic, right? What happens? Imagine there are a lots and lots of services, and we do have only one partition. That means one partition is getting affected. That means there is a load on one partition. If we are just going to create n number of partitions, then probably what we can say, we are going to achieve parallelism and we are going to achieve scalability. Okay. So that's the total idea behind partitions. So partitions basically going to allow scalability, and also it provides a mechanism to achieve parallelism. Got it? So that's the total idea of the partitions. Any doubts in this, first of all? Yes, Suresh.
So it's partitioning, like how it happens. So you're saying that one topic will have multiple partitions. So those partitions are being shared by different services, right? So how does sharing happens? Is there any
You don't
algorithm or
have to worry
something?
about the sharing. It happens automatically. That configuration is already there inside. So here we have actually created 3 partitions for a topic. Can you see this? This is through script. We can
Hmm.
create a number of partitions. Basically, partitions are basically used to achieve scalability and also parallelism, to actually speed up the data retrieval as well as the data storage inside the topic. Okay. That is where partitions are going to basically, control the parallelism and the scalability. But if you
How
just,
many partitions you will be creating? In this
you can
case, we
create
have
n
done
number of
three.
partitions. You can create n number of partitions. Right now, for me, that many number of partitions are not required. But in real time, they
Hmm.
can actually use 100 partitions or 200 partitions according to their load. But here we are actually having a booking service and a payment service. Only 2 different services are getting communicated, and I'm the only user who is using it right now. So I think I don't require any partitions. So that's the reason I have just created 3 partitions. That is actually required for me. Even if it is not, even one partition will also work, because I'm the only user right now, right? Based upon the load, you can actually create the partitions. It's up to you.
But how will you decide how many partition? Based
And one
load
more thing.
means.
So whenever you are actually using partitions, you don't have to worry how the data is actually getting retrieved from which particular partition, which partition has the data. You don't have to worry about that, because we are actually going to write the producer code and the consumer code with publishers and listeners. Those framework will actually take care of the consuming and producing or publishing the messages to the Kafka topic. Okay. So these partitions are basically used to achieve parallelism and scalability. That's the only thing why partitions are really required for topic. And each and every topic will have only one partition. But if the demand increases, let's say there are a lot of users for the particular topic, you can actually maintain n number of partitions to actually speed up the performance of the topic.
Okay. So in ideal scenario, we can have three, five, whatever, however, whatever you want, right?
Yeah.
There is no calculation or anything,
No, no.
correct?
See, basically, you can have, 1 million partitions also, but it is actually based upon your system requirements also. Let's say right now, right now, according to my machine, I can create 100 partitions or 200 partitions also, but partitions basically slows up the system if the CPU size is less. Got it? So right now, I do have 32 GB RAM, right? So based upon the RAM, I can actually create n number of partitions. But if you just wanted to create, 1K partitions, it is basically, once you started addicting to this, creating the partitions for a particular topic, you can actually sense a lot of, what do you say, the kind of response that you are going to get from the topic. If the topic response or the data that you are going to get from the topic, if it is too slow, that means you need to understand that, hey, I cannot create this number of partitions. I have to decrease the partitions, or I can actually increase the CPU size. Okay. So it basically gives the performance also based on that.
So we in the organization will have right to create partitions, or they it's a kind of it's calculated dynamically.
See, basically, initially, once the product is released in the market, right? So they don't know how many partitions are required, first of all. They actually sense it through performance testings. They do have a lot of performance testing, right? How many partitions are required? Let's say they have created 100 partitions. The performance is good, but if the more requests are coming, let's say for 1 million requests, 100 partitions are okay. But for 2 million requests, what they need to do, the response is very slow from the topic. Then they actually have to increase the partitions. But in order to increase the partitions, they have to increase the CPU system resources also, right? They cannot write and increase the partitions. It will not give you that much of scalability and that much of fast response, right? So they have to consider the CPU, and based on that, they can actually increase the partitions. This is how it actually works.
Yeah, got it. So based on based on the what do you call, while doing the performance testing, they will baseline the partition, right?
Basically,
Depending on how much
we
assumption.
basically use no, we basically use JUnit for load testing, not JUnit, JMeter, right? So we'll be
JMeter.
sending 1 million requests. We'll see the performance over there, how the topic is actually behaving, whether we are actually getting the response within a certain period of time or not. We'll just have all those calculations, right? If it is actually behaving very slow, then probably we will reduce the partitions because our CPU is not allowing more partitions. It is actually slowing down. So we will understand from that and we will actually design how many partitions are required. It actually requires a lot of, groundwork, Suresh. It's not something like we have to maintain 10 partitions or 15 partitions, but partitions are basically used to achieve scalability and parallelism to fast up the process.
Yeah, got it. Yeah. And topics you mentioned, like it's a kind of storage associated with the Kafka server, right?
Storage, but
It's
in
memory or
also, we do have partitions. So each and every topic are going to have partitions. Why these partitions are really required? Let's say right now there are 3 partitions. Okay, you, me, and some other person are acting on the same response topic. We do are operating on the same topic. Let's say the topic is having only one partition. It actually slows the performance, right? Little bit. But if you have 3 different partitions, then probably you can operate on one partition and I can operate on one partition and other person can operate on another partition. It actually gives a parallelism task for every one of us.
and
Okay.
topic itself is a memory, right? It's a kind of a storage, like
Storage. Topic is like just like a storage, and topic is a part of Kafka broker. And Kafka brokers are a part of the schema registry, and schema registry is a part of cluster.
When you say storage, that means the memory or something else.
Storage is a memory only, right, Suresh?
Okay. Okay, got it. So there to be, and this message, like they are stored in the, like there will be some serialization and deserialization, right? While sending the data, it will serialize the message.
Suresh, we'll see that serialization part and deserialization.
Okay. Okay, got it.
We have to do that one, right? We'll understand that. Okay. First, let's understand how it is actually working.
And when you install this Kafka cluster, right? I saw there was so many brokers, one something 2, 1, 1, 2. What is that? Like how many clusters, how many servers it got installed? How, like based on what it created?
What is our question, Suresh? You're jumping.
No. What I'm saying is when you ran this Kafka cluster YAML, right? So
there will be a single cluster. No. There will be
just one.
See,
So one cluster, how many servers?
No, 1 second. So you have actually installed MySQL Workbench, correct? Okay. So how many MySQL Workbenches that you can run? Only one only. Okay. But we can actually open multiple windows of MySQL Workbench, but there is only one. Okay. Like the same way, we are going to have one single Kafka cluster. So Kafka cluster is a place where we actually manage brokers along with topics, including the partitions inside the topic.
So last question, like Kafka, you mentioned it's a framework. What exactly that? when you define
Yeah,
it?
see, yeah.
There's
See,
a lot of things like
open
Kafka
source
server.
internet streaming platform itself, it actually has some framework behind the scenes where we can actually use it in our Spring applications in order to communicate with Kafka. You know Spring framework, like that we do have Apache framework also.
Okay, got it. Thank you.
Okay. Yeah. That framework itself provides some control to access and gain control over the Kafka topics. Okay, so this is where we have actually run our, the Zookeeper. First of all, Zookeeper is just like a base for running Apache Kafka. Without Zookeeper, Kafka will not run because that is the server behind the scenes how Apache Kafka is going to run. Okay, so Apache Kafka, if we have to run Apache Kafka, then probably you need to run Zookeeper first, then only Kafka will run. Okay, so that's the total idea. Now, we'll just go to our booking service first. We'll just go to the booking service. Just go to the APIs. I think we do have a service here. Yes. So here we do have something called calling. Yeah. So here call will fail if payment services. So here we are actually calling the payment service with the payment service broker, which is a paying client, correct? So now we do not require this. So what we actually do, delete this one, and I don't require any of these things. I can simply go and remove the entire code. This is not at all required. And here, if you can see that the booking entity is saved, we are just setting the booking ID to this booking DTO, and then we are setting the booking status to pending. Okay, because this is a response that we have actually made it as a pending in the initial state. So now I will just go ahead and remove this complete code. This is not at all required because we need to publish the data to the Kafka topic. That's it. And here I can just return the booking DTO as it is. But how we actually track the booking details based upon the booking ID. So that's the reason if I remove this particular call, then probably we need to introduce one more API. First of all, I just wanted to write this booking ID. And this is a tracking API for the booking details. Okay, so get booking details. And here I just wanted to remove this code and I just wanted to make it void for now. I will just go to the booking service INPL. Instead of that, I will just go to this booking service first. And here I just wanted to pass UUID booking ID. And this is from util get booking details. This is just to track. Okay. So here we are going to get the booking DTO back, and then probably I will just go to the booking API. And here it's a path variable, booking underscore ID. And this is a type of UUID. That's it. And here, what I need to do, this dot booking service dot get booking details. I need to pass the UUID, which is a booking ID. I can simply keep it as booking ID. Y underscore is required. I can simply keep it like this. That's it. Okay. So now what I can simply do, I can just go to this booking service IPL, and here I just wanted to override that method, get booking details from the booking ID. So here what I need to do, I need to use this dot booking repository dot find by ID. This is a UUID again. I need to pass the UUID so that I can get the latest update from the bookings table itself. Okay, so this is actually going to return me an optional. And here what I need to do, booking entity. Okay. So I need to return the booking DTO return because I'm just getting the booking entity, right? So what I can simply do, I can actually use booking entity optional dot get, and here I will be getting the booking entity, correct? But I'll explain you there's a drawback in this. Okay. So let me use the return booking DTO dot builder. And here I just wanted to set the booking ID from the database entity dot get booking ID. And here I just wanted to use the booking amount entity dot get booking amount dot booking status. So entity dot get booking status dot movie ID entity dot get movie ID show date entity dot get show date and show time. And finally, the user ID entity dot get user ID. And do we have anything else? Booking amount, booking status, user ID, seat selected. So entity dot gets seats selected and dot build. That's it. So here I'm actually getting an entity, but what happens if the booking entity optional is not there? That means here we will be actually getting, okay, so here we'll be actually getting an empty entity. So that means the entity is null, null dot anything, null pointer exception. So we cannot use this particular code. Okay, so there is a better way to handle this first of all. Okay, so find by ID, if it is returning you an optional, then probably what you can simply do, you can just delete all this kind of steps and simply you can just use or else. This is a handler supplier, we can use it over here, and here we can actually use new. I just wanted to create one exceptions package over here. And here, I just wanted to create only one custom exception, which is a bookings exception. And we can use it wherever we require. Okay. So this will just extend the exception. And public. String message and super of message. That's it. Okay. I'll just go back to here and here, bookings exception. And here, no booking details found for booking ID. Booking ID, that's it. So here, I just have to use close method signature, that's it. And here, I'll just use this one, I'll just use this one as well, and that's it, okay? So now this is actually going to return me the booking entity finally, not an optional. That's it. This is how we actually write a Lambda for getting these details, okay? So now what I can simply do, I can just go to my handler. And here already we do have some handlers, but I just wanted to create one handler where I need to handle custom exception. So bookings exception. Okay. And I just wanted to use the same thing over here. And so here, whatever the message that I have thrown, I can actually get it from there. And here, I cannot say this as internal server error. I can actually say it as okay and okay. I have seen a lot of articles where if one of the record is not found, they are basically going to return a 404 error status, right? So we cannot use that one, first of all, because let me tell you one simple thing. So right now, we are actually passing a booking ID and we are going to interact with the database. And inside the database, we are actually going to get a record, right? If it is there, if it is not there, we are not going to get a record. That means, do you consider this as a successful scenario or a failure scenario, first of all? So booking ID was passed. Controller is calling the service and service is calling the database successfully. There is a successful establishment. The connection is already there, the database connection. And the database itself does not have any record. So what do you think? We have to give 404 status or okay status will be fine with the exception details? Huh? Come on, guys. Yeah, it's okay status only. Okay. So we cannot give 404. 400 series are basically meant for client errors, right? Do we think that any client error is there here? He's just passing a ID. If that ID is not there, display some message to the end user and make it as a 200 status, right? That's the total idea. Okay. So now I can just go to the booking service IMPL and then we are just going to get it. And in the API, I just wanted to return this directly over here. And here I can actually throw the exception at the method level. And here we can actually return the booking detail. So here, what we can do. So here, I have to use response entity in order to return OK status also? Because it is not required because for any get API call, by default, the response is 200. Okay. I don't have to say again that new response entity. Okay. And then the booking video. HTTP status dot okay. I don't have to use this first of all. Okay. That's it. So instead of doing this, we can actually do like this because unnecessarily we don't have to write a response entity and return HTTP status 200. By default, for any of the GET API, the default status is 200. So I don't have to define that code again. So that is not considered as a best practice again. Okay. So that's the total idea. So now, so this is the tracking ID where here inside the booking service, we have eliminated the call to the payment service with the find call. But here, what we need to do, we need to publish booking details to Kafka topic. Okay, which topic it is? Payment request topic. So that the payment service can listen to this payment request whenever there is a data inside this topic. But what we need to do, first of all, okay, we need to define some set of resources over here. We need to define some bootstrap servers. That means for how we are actually defining the database details through the JPA, right? So through the application YAML file, the same like for Kafka also, it is going to happen the same. But before that, you just go to the pom.xml and add one dependency, which is a Spring-Kafka. And this is from org.springframework.kafka. That's it. And once you do this, you can just actually go to the application.yaml, refresh this so that it can download the details of the Spring Kafka libraries. And once that is done, we can actually go and mention Kafka over here. And so since booking service is acting like a producer, but it has to act like as a consumer also. But let me define the producer here. So here I just wanted to define Bootstrap hyphen service. I'm not getting the pop-ups. I don't know. Yeah. So here I'll just say localhost 19092. These are our the Kafka broker related things. If you just go to the infrastructure, Kafka broker 1 is exposed on 19092, 29092, and 39092. So we do have to define the same thing. So I just wanted to copy this and 29092 and 39092. So these are the Bootstrap servers for the producers. Now we need to define something called the key serializer. Okay, so here in the key serializer, I just wanted to use org.apache .kafka .common .serialization .string serializer. I'll tell you why I have used this. Okay, so if you just see my presentation over here, so yeah, can you see this one? So here basically I have used, yeah. So this is a code to send data to topic. This is acting like the producer. But here, can you see this? I have actually taken Kafka template, the key as string and the value also as a string. Okay. So here the first key is basically the topic name, and the second value, that means this is a key value pair, right? So the first key is itself is a topic name, and the value is the data that we are going to store inside a topic. Okay, so that's why it is called a string serializer. And here we do have something called a value serializer. Okay, so while using Kafka template, we can actually use a key value pair in order to send the data to the topic. So the key mentions the topic name and the value itself is the data. Okay, so here I can actually define org dot Spring Framework. I'll tell you why I'm using Spring Framework, because I just wanted to send this booking details as a JSON in the form of string, because that is the best convention to store the data. Okay, so here I can just use Kafka dot support dot serializer dot JSON serializer. You don't have to remember this. These are already available. I know it because I was working on it from past so many years. Okay, so this key serializer is basically from the Apache Kafka itself, but here I'm just using Spring Kafka related JSON serializer. And if you just see the code over here, we have actually used the key as string and the value also as string, right? But here that is the string, but we need to convert that string into a JSON so that we can bind it to the booking details or the booking DTO JSON again. So I'll tell you what happens behind the scenes over here. Okay, so this is just a configuration. And here what I can simply do, right? So here I just wanted to create another package. You can actually create another package, Kafka. And here I just want to create one sub-package, publisher. And inside the publisher, I just wanted to create booking service, Kafka publisher. And I just wanted to annotate this with the service because it is just going to perform some service. So this is a place where we need to write code to publish message to Kafka. Okay. And we just have to maintain a listener also, because it booking service has to act like as a producer, as a consumer also. So here, listener, and here I just wanted to create a class booking service Kafka listener. And this is also a service. Okay, so basically this class is basically meant for consuming data from Kafka topics. That's it. Okay, we'll write the code. But here, what is this? Listener. Rename file. That's it. Okay, so now once this is done, what we can actually do, we can actually start our booking service to let's see what happens behind the scenes. So we have actually provided this application.yaml with this bootstrap service. So this is just a producer, but let's see what happens. Let's start this application and see if there are any errors or not. Okay, so there is some error. Port 8081 is already in use. How? Oh, okay. So 8081, we have actually given it for the Kafka schema registry, right? So we need to change our port over here. So let's follow some conventions. For booking service, I just wanted to maintain 9091, or let's say we actually start our services with 7070. Okay. And for payment service, we can actually use 7071. Okay. And let's start the application again, because those ports are already taken by the Kafka schema registry. If you just see this, so 8081 is already taken by this schema registry. We cannot use the same port again. Okay. That's why I have renamed the port number of my service to something else. Why it is always taking this one? One second. Okay. But okay, we need to run Eureka server first, right? But let me understand why this 8081 is still being taken. Okay, let me start the, let me stop this first of all. Okay, this is a booking service too. I don't have to use this. I will just delete this. And I'll just start the movie services registry application. And then we can start the booking service application. Okay, so this booking service application will now start, because that is a separate instance that we have created, and that is going to have server.port as a configuration parameter as 8081. So it is always going to take 8081 as a parameter. Okay, so that's the total idea. And I just wanted to run this booking service application, and let's see if everything works fine or not after adding the schema. That means after adding the bootstrap service of the brokers of the Kafka topic. What happened? It started, but it's taking time. Yeah, now it is registered, and now good. We do have a very good progress then. So there are no errors. That means this configuration is perfectly working fine. Okay. So now what I just have to do, right? I just have to, use this booking service Kafka publisher. And here, basically, we can actually use private Kafka template And here we can actually define string comma string Kafka template. That's it. You can just do auto while. And the instance will be provided by the application context factory. So how it is actually going to do? So how we are actually auto wiring the JPA repository, since we have provided this configuration, it is going to establish a communication with the database. The same like for the Kafka also, this is a producer. With this configuration, the Kafka template will be working on the go. Okay. So here I just wanted to public. No return type is required here. Push booking details to payment request topic. And here I need to get the booking details in the form of string. Booking details JSON. Okay. Now how I can pass the data? So if I just go inside this, here I need to publish the data, right? So here what I can simply do, I can simply go and auto wire this. Booking service Kafka publisher. Okay. And here I can simply go over here, and here I can just use this dot booking service Kafka publisher dot push this details to the topic. But here we need to convert this booking detail to a JSON, because that is the correct format. Because since we have used in the topic, basically we can actually pass strings, as well as we do have something else, which is something called Avro. But this is a very complex part. I think we can actually use this for transactions related handling techniques. But we can actually use a string as a data to store into the topic. Okay, we cannot store something like booking detail directly inside the topic. We need to store that in the form of a string, okay, or in the Avro format. So here what I just wanted to do, so in order to convert this DTO to a string, right? So what we need to do? We need to auto wire object mapper. Everyone knows about it, right? I have actually taken a session on this one as well. This is a mapper provided by the Spring, where we can basically use the mapper in order to convert that into object mapper dot write value as string, and I just wanted to pass this booking DTO. That's it. Okay. So here it is just going to throw some exceptions. So here I'll just go and add the exception over here. That's it. And if I just go to the booking API, this is being called from this API. So this will also have an exception. So let's add that exception at the method level. That's it. Okay. So now this is just going to publish a message to the Kafka topic. Now what we need to do, we just have to go inside the payment service. And we need to maintain the same structure, Kafka, and as well as publisher and listener. So I just wanted to create a publisher and payment service, Kafka, publisher, and service. And I just wanted to create another package, listener. Payment service, Kafka listener. So I get this with @service. Okay. So now what I just wanted to do, I'll just write one method, public void receive data from payment request topic. So here I just wanted to receive that data in the form of Spring booking details JSON. And here I need to annotate that with Kafka listener. I don't have a dependency. I just have to add Kafka also inside the payment service as a dependency. That's it. Just refresh it. And once this is done, we can actually go to the payment service. And here we do have something called Kafka listener. Okay. So here we do have something called some attributes. You can actually give topic names. So here I just wanted to give payment request because that is the request payment request topic which we need to listen. And here we do have a something like payment request. Group. Okay, I'll explain you about this group ID, but I think it's almost 10:20, man. It will take a lot of time because a lot of coding is involved inside this. So tomorrow we'll just resume from this particular place. And tomorrow you'll be having a complete knowledge on the Kafka publishing and the listening part. So tomorrow we'll continue from here. Okay. I think it's almost been 10:20. So let's wrap it from here. Okay. So I think I can meet you all tomorrow at the same time. So try to join very early. So today I have actually been in the class at 9:05 exactly. So please come early so that you cannot miss the initial session time. Okay. So thank you and have a great day. I'll meet you tomorrow. So I think this application is not going to run action. Tomorrow I will be sharing you the zip. Okay. Don't worry. So today you can just explore your knowledge on Kafka. So you can explore some articles. I think that will be a lot more helpful. But the process that we are going to do is completely different. Okay, so it's not explained in any of the articles. Some YouTube tutorials have publisher and producer and consumer, but that is completely different from here. Okay, so that's the total idea. Okay, and I just wanted to wrap it over here. We'll just continue from tomorrow. Okay. I think I can share the PPT to everyone. I think um, let me share it right now because otherwise I will be forgetting it. Let me go to the Telegram. And here, Java return project file. And yes, you can just read about this. Just a sample introduction to Kafka, nothing there inside that, but probably in the practical, we will discuss a lot. By end of the day tomorrow, you'll be getting a complete picture, what is Kafka and how to publish and, consume the messages from the Kafka topic. So tomorrow we'll see all those kind of things. Okay. Yes, Suresh.
Yeah, this Telegram ID I don't have. Like where can I get all the details? Whatever you're sharing. I have only GitHub link.
No, right now
So
you are not there inside the Telegram.
no, I don't have. I'm not sure where.
Okay.
Do I need to create ID or
Let
you will
me,
be
I
providing?
think if I do have an access, let me share that over here. I think I can share it to everyone. 1 second. I'll share it inside this one itself.
I can copy from there.
Oh, yeah, I think I can share it right now. I think this will be fine. Hope you have all got the details of the Kafka PPT. Okay, just go through that. Probably we will discuss more points about Kafka tomorrow. Okay. Yeah.
Okay.
And happy learning, guys. Bye.
Thank you.